Sorry about that. Now it's recording. Dang, I keep on forgetting. Okay, f of x, and hopefully we can integrate. This won't be that bad. That looks like x cubed minus 4x plus c. Plus c, and we can see that this is going to be some sort of cubic, something like that, and it looks to me like it did work, right? Something like that. The plus c is telling you if it's either up, higher, or lower, because it's a constant. So pretty much what I want you to know, that slope fields is just talking about the slope at this function. So you don't have to continue it actually in the exam. It will just be parts of it. So whatever the case may be. So pretty much what you need to know when solving a differential equation, sometimes they're a little too difficult. So we model them as slope fields. So this is often seen, guys, when modeling a population. So like a population of a certain animal, and then people need to know like what's going to happen with this. Is it going to go extinct? Is it going to reproduce too much? Like that's how these are mostly used in real life. So pretty much what is a slope field? It is a differential equation at every xy point. And we have the slope at each, at a given point. So in summary, if you're gonna go ahead and write this down, pretty much a slope field is an xy plane covered in slope elements for each segment in an x and y. And I believe when we were taking the mock exam, it had a little question like that, and we're all freaking out. We're like, what is this? Like, we don't know what it is. Because they had 1, 2, 3, 1, 2, 3, 1, 2, 3. And the function, I'm sorry, the graph had these little points. And in these little points, we had little lines like that, and so forth. And we were like, what is going on? So these are the slope fields. Okay. These notes are on the PowerPoint in case you need more time to write them down, but pretty much it is this information right here. You can have an XY plane, and each of these planes, you have little slope segments. They could either be horizontal or positive slope, negative slope, stuff like that. Here's some more examples of slope fields. Since we don't have an exact value C, right, when we integrated it, we could have a variety. We could have this green one right here being the function, or this pink one, or this blue one right here. It all depends. I know some of us don't have a printer, so what I went ahead and did, pretty much the easiest way to do this on your notebook is draw your XY axis, so an XY axis. And what you're gonna go ahead and do is you're gonna go, and each point from 1 to 3, so this is a 6 by 6, right? Because you have 1, 2, 3, and then -1, -2, -3. Each point, you go ahead and make a little solid dot. So honestly, these will be given to you in the exam, well, a normal traditional AP exam. And you would just go ahead and decide, are the slopes, well, let's go ahead and do when y equals 1. The slope is going to be a positive 1. So a positive 1 slope looks like that for all the y's. If the slope was 0, right, that's a horizontal line, it would look like so. For all the y's equals 2. If the slope was negative, I don't know, -7, it would be down. So very steep down, right? Like -7 versus something that has a slope of, I don't know, -1 would be not as steep, right? It would be decreasing a lot less at a slower rate versus the -7 versus the -1. So pretty much that's what we're going to go ahead and do. We're going to go ahead and have a little axis, and we're going to go ahead and put these 3 dots in each quadrant. That's going to help us do our slope fields. So ideally in classroom, what I had planned was a little matching activity because these are pretty fun and they're not that difficult once you get the hang of it. But as of right now, I had to move it a little bit so we can do it on Google Classroom. But let's see how that works. Okay, the first example, we have the differential equation. Oops, the differential equation is this right here, negative x 2y. Now, I'll give you a couple seconds so you can go ahead and draw your little axes, your little 6x6. Remember, all you really need is the x and y axes and the 6 points in each quadrant. Okay. So the way I like to do these, I just make an XY table. And the last part, the last column is a dy dx. And all you have to do is sub in points. Okay, so let's go ahead and begin. Let's go ahead and pick what is gonna happen at the origin. I always like to know what's happening there so that the origin is at 0, 0, right? So if I go ahead and substitute 0, 0 into my function, I get negative 0 divided by 2 times 0. So hopefully you guys see that this is an indeterminate form. So this is undefined. So unfortunately at the first one, guys, I cannot draw anything, not even a dot. So let me go ahead and erase that dot right there. So unfortunately that one, I couldn't do anything. Okay, let's pick a different dot. Let's go with 1 and 1. So this is negative 1 and 2 times 1. So all we're doing right here is we're going to start filling this, and this looks to me like negative 1/2. So at 1, 1, right, at this point right here, I'm going to go ahead and put the slope of negative 1/2. So it's going to be decreasing like so. Let's try a different point. Does anyone care to shout one out? All we're doing, guys, is we're filling in this little part. Yeah.
3,
2, 1.
2 and 1. So if I put a 2 for my x, I got negative 2 and 2 times 1. That gives me negative 1 at 2, 1. So at 2 and the 1, I get this little negative 1. Yes. So all you're really doing, guys, is you're substituting in points. Let me go ahead. So go ahead and start filling it out. And once you go ahead and do that, we'll check with mine. Let's go ahead and let's go ahead and pick a different one. Let me go ahead and pick. I want to see what's happening at 2, 2. So 2 and 2. So that gives me negative 2 over negative 4, which is also negative 1/2. So right here, I also have the same steep. And for curiosity, I'm going to try it when it happens at negative 1 and 1, because I think I found a pattern. So that is 1 over, what is it? 2. What am I doing? Negative 1, that's 1. 1/2 at negative 1 and 1. Okay. So go ahead and start filling in the points, and all you're doing, guys, is filling in the slopes. Let me go ahead and make myself another XY axis because I'm making a bit running out of space. Hopefully you're seeing this pattern as well. When I have y equals 0, I'm always going to have undefined because I am dividing division of 0 has undefined. So whenever y equals 0, guys, this right here, it should be blank. So nothing should be on this line right here. Let's go when x equals 0 and y equals 1. I'm going to go ahead and substitute. Hopefully you can see that all of these will be 0. So I found a little pattern right here that whenever x is 0, I should have this right here. Was everyone able to see that pattern? Whenever my x's will be 0, I got 0 pizzas divided by however many people, we all get 0. So this one I'm starting to see a little pattern right here. Okay. Eventually, guys, we just get faster and faster at doing these, but all we're doing is substituting. Let's go ahead and pick a different one. Let me find out what's happening at 1 and 2. So at 1 and 2, I put 1, that's negative 1 over 4. So that should be a slope pointing down. If I go, sorry, that's negative 1/4. Let's go ahead and pick, let's pick on this quadrant number 4. 1 and negative 1, let's see what happens there. I got negative, I got positive 1/2. So what you guys got? Okay, so it looks like it's gonna be reflecting just from what I did earlier before. This should be something like this. So I won't spend too much of your time. So this should be something like so. So it should be like little circles. Except that on the, when y equals 0, it is undefined. So eventually, guys, you just see patterns here. I know this wasn't my best one, but I made some way easier ones in the homework. So pretty much what I was trying to model here is something like that. So like there would be circles like that. And they would be reflected here. Normally, guys, these would be, well, for the homework, there will be multiple choices, but don't want you to freak out on them. Okay, so there's 2 important things to know here. When, let me go ahead and write it here, when y equals 0, what happened? Well, if I go ahead and check, when y equals 0, I got division by 0, right? And can I divide by 0? 0? No, right? So right here, when y equals 0, I don't want to see any lines, guys. It is understood that if you leave it blank, it is equal to undefined. So blank equals undefined. Now, I know because I struggle with this too. A lot of us notice that, hey, whenever it is 0 divided by a number, sometimes we like to say, oh, that's the same thing as saying a number divided by 0. Well, that's not the case, because this right here, 0 pieces divided by people, that's 0 slope. And a slope that is 0 is a horizontal line, versus whenever we have a number divided by 0, that's undefined. So this is a vertical line, but we don't draw vertical lines. We just leave them blank. And then a 0 is a horizontal line, which are these right here. When x was 0, we had horizontal lines. And as long as these don't touch each other, guys, you're golden. They don't have, they could be short as long as they don't touch each other. Okay. So the next part of this question, they want you to go ahead and draw just one of these. So sketch a possible solution to this differential equation that passes through the point 0 and 1. So right here. So just an equation looks like it would be something like that, right? Whoops, I totally messed that up. So some half circle, some semicircle like that, that does not touch here. Any questions on that so far? I know this one was my best example, but it's pretty much, it was just something that had both the undefined and the slope of 0. So that's why I picked it. But it's just substituting, guys. Any questions? Let me check the chat box in case. Yeah, no, these are not that bad, guys. These are okay. And the ones I did for homework have a lot more patterns. So I think the only pattern we were able to see here was these right here, the slopes. These were all the same slope. Okay. All right, let's go ahead and do a different one. So you guys don't have to go ahead and draw it perfectly. And we're gonna go ahead and check. Does this slope field match a given question? So the more and more you try this, guys, the easier it gets to do. So let's go ahead and see some points. So let's pick this point right here.
Mr. Pasina.
Yes.
Okay, so for the dy dx, is it always going to follow that formula, x over y times 2?
No. Remember, these are differential equations. They could be anything. Like, let's look at this slide over here. These were all different ones. Those will change every time.
Oh, okay.
And therefore, the picture changes also.
Okay, thank you.
Yeah, no worries. Let's go ahead and try this one. Pick a random point, guys. I really don't care which one. Eventually, you'll be able to eliminate them. So I like to pick 0, 0 because I like to know what happens at the origin. So pretty much at 0, 0, you can make your table again. dy dx. And when it is 0, this is 0. I substitute them. And it looks to me, guys, it looks horizontal, or at least to all of these right here, they look to be the same. So whatever 0, 0 is, it looks like it's the same thing for 1, 1. So if I go ahead and put 0, 0, which appears to me horizontal, I'm going to check the first one. If when x equals 0, when x equals 0 and y equals 0, it does work out. It looks like it is 0. So this still works. 0 minus 0 still works. 0 plus 0, all of these work for the first one. Okay, so probably not my best pick. Let's go ahead and try another one. When, I don't know, 1, 1 looks pretty interesting to me because it's also 0. And it appears like it'll also work. 1, ooh, actually no, when this is 1, and I put in here 1 plus 1, in this case was 2. So does this look like a slope of 2 to you? Hopefully not, right? Because we just said the first slope was 0. On B, on the other hand, 0 minus 0, that looks like it works. 0, I'm sorry, what am I doing? 1 minus 1 works. Negative 1 plus 1 also works. And 1 squared minus 1 also works. So we're able to get rid of 1 only. Okay. Alrighty, let's go ahead and pick a different number. Does anyone want to shout anything out? No?
2, 2.
2 and 2. If I put 2 and 2 on the remaining ones, I got 2 minus 2. That also gives me 0, so that was still in the race. I got negative 2 plus 2. That's also in the race. I got 2 squared, which is 4 minus 2. That's 2, so this one's out of the race. Okay, so far so good. It appears like no matter if we pick similar numbers that are diagonal, these will continue to work. Continue to work. So we're gonna have to pick up something a little different. So some other number, guys. Any number?
Negative 1, 0.
Negative 1, 0. So let's pick negative 1. So what happens here? So negative 1 into the B says negative 1 minus 1. That's negative 1. And does that slope look like negative 1 to you? Looks like it's rising, so it doesn't look like it's going to work. For C, it says negative 1 plus 0. That is 1. This right here does look like a slope of 1 to me, so I'm going to lean on C. Any questions on these so far? They're not that bad, guys. All you really have to do is pick random numbers. And eventually you'll see that, hey, there's a pattern right here. So, and then there was a pattern right here. So that's why some of them kept on working. But if you start picking random different numbers, that's how you can get rid of a lot of these. Okay. Can I continue?
Sure.
Yes, what's up?
Oh no, I just meant you can continue.
Oh, thank you. Awesome. These often trick me a lot because, to be honest with you, the worksheet I got it from had like from -10 to 10. Would be I guess a 20 by 20 because it had -10 on the lowest and height was 10. So it was a little difficult to see. So I went ahead and regraphed it to make it easier for us.
And can you go back to the previous one a little bit because I got a bit distracted.
Yep. What part?
Yeah, the previous one over here.
Okay.
How is it in 1 and 1? Where'd you get 0, 1, 2 from, and then -1 and so on?
I'm sorry, one more time.
What is all the numbers 0, 1, 2, and then -1? Where'd you get that? Are those test numbers?
Yeah, test values. Yeah, you pick one. Pick any of these. Like anything you want, and eventually these will not cancel out. You're trying to find out which graph gave you this.
Okay. Hang on. Sorry, I got distracted.
You guys know trig functions is coming up next.
Yep.
Alrighty. Can I continue?
Hang on.
You just pick random values, and eventually some of them cancel out.
Okay.
Awesome. So this one right here, pretty much what we're gonna go ahead and see is which one should be the value here. So what I like to do whenever, especially when they're trig functions, guys, is right here. Guys, keep the chat box for questions only, please. Whenever they're trig functions, I like to go ahead and keep them to check what's happening right here, because keep in mind, if you have a function that starts at its maximum, right? What does that remind you, sine or cosine? Cosine, right? And when we have a function that starts in the midline, right? Hopefully we still remember pre-cal. This is sine. So that's what we're gonna go ahead and see. And we already can go ahead and see that we can follow this right here. Something like that, something like that, something like that, right? And we know this is a trig function, so it's just gonna go ahead and continue. Something pretty full like that, and so forth. It doesn't have to be perfect, guys. But hopefully we can see that it passed through the midline, then it increased, right? So hopefully we can see that this is not cosine, right? Not cosine at all. And in fact, this one has with a variable y, so that would be a vertical cosine, and that was not something we had. So we're left with these two. Hopefully we remember that sine, if it goes this way, this is actually the parent function of sine of x. I wanted to pass through the origin, but we don't have to because it could be shifted up or down. It could have been right here, or it could have even been right here because of the constant. Oops, I totally messed that up. Here you go, something like that. The value C tells you the height change. It could be a height of 10, height of -10, or height of 0. Let me check the chat box. No, remember guys, you don't derive them because the slope field is the derivative. So the little slopes, the little arrows, guys, these right here are the dy dx's. Inside the dy dx, the slope field, right, the differential equation is the original function, which we have here would be this one. So the dy dx is the slope field. Does that make sense? Just like in the do now, guys, let me go back. We saw the slope field, but remember inside the slope field, we were able to find the function, right? So the little slopes are the e to the x, right? But the function itself, well, that's not a good one because it's the same thing. But here's a better one. The slope field is the little slopes, but the function is hidden inside plus c. But sometimes it will give us initial point. So we can go ahead and say, hey, you know what? Pass it through 0, 0. Oh, I know how to pass it through 0, 0. And that's how we find the original. So that's how we find C.
Wait, so as in like just plugging in a certain number to, like, let's say 3x squared minus 4. Like, for example, you're putting x equals 1. You just plug that in there, something.
Yeah, and then that's how you can get the function. Yes, sir.
All right.
They'll give you a point. Let me check the chat box because you didn't integrate. Yes, Katie. So this slope field, the lines, is for 2x. Oops. To get what the function was, I integrated and I got that the integral of 2x is x squared. Don't forget your plus c. That's how I can find out any of them. So I still have my meeting at 12 for the questions that will be asked or what we'll be enforced to do. But as of right now, Angel, I don't know. But as of like a normal multiple choice, these were not that bad. Actually, in our mock test, it asked what could be a possible function. So like in the mock test that you guys took, it was a question like this, and they'd ask you A, B, C, what is a function? X squared, negative x squared, I don't know, 2x squared, I don't know, something like that. So in our traditional AP exam, yeah, that's a perfectly easy question. Will any question give you the original function? Yeah, that too. Also, yeah, I understood your question now, Andrew. Yeah, that would work too, but that would be on a traditional one. Since you only have 3 free response questions this year, I don't know how much this will be used on, to be honest with you. Any other questions, guys? Other than that, that's all I had. There's videos, guys, and I even attached the link to the, whoops. This would be the lesson from College Board. And this one is a pretty good lesson. This is what I used to review on this topic. So both of them I actually used to review, but this one's from College Board. And then this one's the one I found on YouTube. It's pretty good. And it has lots of examples. Any questions, guys? If not, I have a meme for you guys from Animal Crossing. No? So yeah, this has become very popular. I didn't know where it was from to begin with, but it's a game called Animal Crossing. So I was like, oh, okay. Yeah, I didn't get it to begin with first, but I'm like, oh, they probably know what this is about. I should play it. Once I get the hang of this distant learning, I do plan on seeing what else I can do. It's for the Switch. Oh, I do have a Switch. Okay, so all right. And that is all that I have, guys. If you have any questions, go ahead and unmute yourself and anything. If not, I don't have pre-call after this, so I can share with you guys if that's the case. I'm gonna go ahead and stop recording.
Sir, are you gonna place the PowerPoint with the written notes in it?